Okay, good morning everybody. This is my first video for you for today. We're going to talk about something called arc length. And so to understand what arc length is, we need to go back and think about what we learned already about arc measure. Because arc length and arc measure are actually two different things. So we've already learned that the measure of an arc refers to the number of degrees out of 360 that an arc spans around a circle. And we've already learned that you can find the measure of an arc by looking at the central angle that intercepts it. So of course, in this case, if this angle is 90 degrees, the measure of this arc would also be 90 degrees. However, today we're going to talk about arc length, which is not measured in degrees. Arc length is an actual distance. It's, if I was a tiny little person and I was walking along this arc, the arc length would be how far am I actually walking? What's the distance along this arc from point A to point B? And that's going to be measured in, a unit of measurement like centimeters or inches or something. So to understand arc length, we have to understand circumference. Now this is a concept that you have all learned before. The circumference of the circle is, of course, the distance around the circle. You can think of it as like the perimeter of a circle. And it's a very simple formula. It is simply the diameter times pi. Sometimes the diameter is written as 2 times the radius. And so you may see this formula sometimes written as 2 pi r. That's kind of another famous way to write it. But notice it's the same thing, because 2 times the radius is equal to the diameter, vice versa. So, to understand how we find the arc length, we have to talk for a moment about fractions, specifically fractions of a circle. So looking at this circle right here, it says arc AB is what fraction of circle T? Well, this is a 90-degree central angle right here, which means the measure of this angle is 90 degrees. And 90 degrees out of a total possible 360 degrees would mean that arc AB is 1/4 of the circle. What fraction is arc CED of circle O? Well, that would be this entire arc right here. Now this is actually a semicircle. We can see that CD is a diameter. So this is exactly half, right? This is 180 degrees for the arc measure. And 180 degrees out of a total possible 360, that arc is half the circle. How about arc EF? What fraction of circle P? Well, EF is this arc right here that's marked as 120 degrees. Right, which means the central angle here is also 120 degrees. But regardless, if this is 120 degrees of the entire circle, that's 120 degrees out of a total possible 360. EF is 1/3 of the circle. And so if you think about it, this gives us a clue as to how we're going to find arc length. Because if I know how to find the circumference of a circle, and I know what fraction of a circle the arc is, then I can multiply those two things together, and that would give me the arc length. And so that's kind of our big idea here, is that the arc length of a circle is equal to the fraction of the circle multiplied by the circumference. The fraction of the circle, as we've seen, is equal to the arc measure over 360. The circumference we know is diameter times pi. And so this gives us a formula that we can use for all arc length problems. So arc length will be equal to the arc measure, I'll just use a lowercase m, over 360 times the circumference. The circumference is diameter times pi. And here is our arc length formula. So let's try it out. On the back of this handout, if you're following along on your own, there are some practice problems. So let's jump to the back side here. I'm going to write down my formula that I just derived. So arc length is equal to arc measure over 360 times the circumference, which is diameter times pi. If the radius of the circle is 24 and the measure of angle BTA is 60, what is the length of arc AB? Notice they're not asking for measure, they're asking for length. If we wanted to know the measure, we would know that because this is an inscribed angle of 60, this arc measure here would be twice as much. This would be a 120 degree arc measure. To find the length of arc AB, we're going to use this formula. And notice that for our formula, we only need two things. We need the measure of the arc that we're looking for, and we need the diameter of the circle. Or, of course, they could give us the radius, because if we knew the radius, we'd also know the diameter, and vice versa. In this case, we're given the radius is 24. That tells me the diameter is twice as much. So my diameter is 48. So let's see what we have here. Arc length is equal to arc measure over 360 times the circumference. My measure is 120 degrees. My diameter is 48. Now I'm going to pause right here. You may be tempted at this point to grab your calculators and just type all this in. Now that's going to give you an approximate answer. However, what we are going to practice today is leaving our answers exact, meaning in terms of pi. I'm not going to replace pi with about 3.14. I'm not even going to use the pi button on my calculator. I'm going to leave the pi here, and my answer is going to have a pi in it. This is called leaving the exact answer in terms of pi. So what I'm going to do first is look at this fraction and see if I can simplify it. Well, of course I can. 120 over 360, that's 1/3. So I really have 1/3 times 48 pi. And 1/3 times 48, well, that's 16. So what I really have is 16 pi. This is my final simplified answer. My answer would be in centimeters. So the length of arc AB is equal to 16 pi centimeters, leaving my answer in exact form in terms of pi. Let's do a couple more. AD and BD are tangent segments. Circle C has a radius of 10. Find the length of arc AB. So once again, we're going to need the measure of arc AB, and we also need to know the diameter. Well, we are told right here that the radius is 10. So right there I know that my diameter is 20. For the arc measure, let's do a little work here. So I'm told these are tangent segments. If I draw radii from the middle of the circle to each of those points of tangency, I would know I have right angles here and here. That's a property of tangent lines or tangent segments. And now I have this quadrilateral where I know this is 45, 90, and 90, and then I'm missing this angle here. Well, now I can figure out what this angle is. So this angle right here would you can take 360 and subtract 90, subtract 90, subtract 45. And so you would get 135 right here. And if the measure of this central angle is 135, then the measure of arc AB is also 135. So now I have enough information to find my arc length. So going back to my formula, arc length is equal to arc measure over 360 times the circumference. I now know the arc measure is 135. And I know my diameter is 20. And at this point, I can simplify this and find my final exact answer. So let's go ahead and simplify this fraction. And if you simplify this fraction, you're going to get 3/8. And here I have 20 pi. And 3/8 times 20 pi. 3/8 times 20 is 15 halves. So we have 15 halves times pi. And when this happens, you can just move the pi into the numerator, and there is our final answer. So my arc length is 15 pi over 2. Again, leaving my answer exact in terms of pi. A couple more. Example 3. The length of arc ROT is 116 pi. What is the radius of the circle? So here they're kind of asking us to go backwards, right? So they're giving me the length and they want me to find the radius. Well, let's go back and start with my formula. Arc length is equal to arc measure over 360 times the circumference. And let's figure out what we know here. We know the arc length. That's given to us in the problem. So I'm going to plug in 116 pi. Do I know the arc measure? Well, let's look over our diagram. So arc ROT, this is a major arc. Oh, they give me here that this is 120. Take 360, subtract 120, and we get the measure of that missing arc, that major arc. So that, of course, would be 240. So the measure of ROT is 240 degrees. And the thing that's unknown here is my diameter, right? And I know it's asking for the radius, but if I can solve for the diameter, then I can just take that and cut it in half and I'll have the radius. So the D is the thing I'm going to be solving for. So let's go ahead and clean up this fraction right here. Now 240 over 360, that simplifies to 2/3. And I know this looks a little scary. There's fractions, we got pi, but the algebra here works out pretty nicely. If I have pi on this side and also pi on this side, I can divide both sides by pi, essentially canceling those out. And so what I have here is 116 on the left side now equals 2/3 times the diameter. And now to solve for diameter, you can either divide both sides by 2/3, or you can multiply both sides by this reciprocal, 3 over 2. Okay, either way, we get 116. If we divide it by 2/3, we would get 174. And that's my diameter. And to answer the final question, which is what is the radius, we cut that in half. And I'm done. Okay, last one. Here's a question that does not have a diagram, so we might want to draw our own here. Circle B has an inscribed angle ABC with a measure of 70 degrees. Remember, an inscribed angle has its vertex on the edge of the circle, not the center. This is 70 degrees. Arc AC has a length of 10 pi. So again, they're giving us the length here. This has an arc of 10 pi. Find the exact diameter. So this is similar to what we did above. Okay, we're going to work backwards to figure out the diameter of the circle. So I have the length. I just need to figure out the measure of arc AC. Now I know the inscribed angle is 70, which means this arc measure is twice as much, 140. Now I have everything I need. I'm going to do arc length equals arc measure over 360 times the circumference, which is d pi. Arc length is given to me in the problem as being 10 pi. Arc measure, I figured out, is 140. And I'm going to be solving for the diameter. So once again, I'm going to simplify this fraction if I can. So 140 over 360, and this gives me 7/18. Just like in the previous problem, I have a pi on both sides. Those can divide away, essentially cancel out. And now I'm left with 10 on the left side and 7/18 on the right side. And again, I can divide both sides by 7/18 or multiply both sides by the reciprocal. But either way, if we solve for D here, we will get, grabbing the old calculator, let's see, this turns out to be, well, it's 25 5/7. As an improper fraction, that would be 180/7. And there is my diameter. Again, leaving my answer exact. I know that's kind of an ugly fraction, but that's the exact answer. We do not want decimal approximations there. Okay, so that brings my video about arc length to a close. Hopefully that was helpful to you. Please check out my second video where we are going to talk about sector area. And then you'll see I've posted an assignment to practice both of those concepts. All right, as always, take care and have a great week.